we need to prove the following. So let's begin from the left hand side of a given expression. So on the left hand side we have tangent of A divided by 1 minus cotangent of A. But we can use the fact that cotangent of A, that's the reciprocal of the tangent function. That means we have 1 over tangent of A. So we will replace cotangent of A with 1 over tangent of A. Similarly, for the second term, we have cotangent of A in the numerator. So we can replace it with 1 over tangent of A whole divided by 1 minus tangent of A. So this will be now equals to, now for the first term, we're going to multiply both numerator and the denominator with tangent of A. So tangent of A times tangent of A gives us tangent squared A. Then we have tangent of A multiplied to 1, so that's tangent of A, minus tangent of A times 1 over tangent of A, so that's simply 1. Plus, here also on the second term, we are going to multiply both numerator and the denominator with tangent of A. So in the numerator, tangent of A times 1 over tangent of A, that's simply 1. And in the denominator, we have tangent of A multiplied to 1 minus tangent of A. But what we'll do, we'll rewrite this. Instead of writing it as 1 minus tangent of A, we're going to write it as tangent of A minus 1. So all we have done is taken negative as the common factor. So this is going to now give us tangent squared A divided by tangent of A minus 1 over tangent of A times tangent of A minus 1. Now we can combine the two terms. So our common denominator, this will be tangent of A multiplied to tangent of A minus 1. So in the numerator, we're going to have tangent cubed A minus 1. Now tangent cube A minus 1, this can be also expressed as tangent of A whole cubed minus 1 cubed divided by tangent of A multiplied to tangent of A minus 1. The whole reason we are expressing the numerator in the form tangent of A whole cube minus 1 cube, because we know the identity A cube minus B cube, that's given by A minus B whole multiplied to A squared plus AB plus B squared. So if we consider A to be tangent of A and B to be equals to 1, that means our numerator will become tangent of A minus 1 whole multiplied to tangent squared A plus tangent of A plus 1 divided by tangent of A multiplied to tangent of A minus 1. So tangent of A minus 1 will get factored out from the numerator into denominator. Now in the numerator, what we have here is tangent of A plus 1 plus tangent squared A whole divided by tangent of A. Now 1 plus tangent squared A, that's a trig identity. So 1 plus tangent of square, let me state it, 1 plus tangent squared A. So that's secant squared A. Now we can replace this value with secant squared A. We're going to get tangent of A plus secant squared A whole divided by tangent of A. Now we're going to divide each term with tangent of A. So tangent of A divided by tangent of A will be 1. Then we have secant squared A divided by tangent of A. Now we can rewrite the second term as 1 plus secant of A multiplied to secant of A divided by tangent of A. Now let's simplify secant of A over tangent of A. So we have secant of A. We know that that is the reciprocal of the cosine functions. We have 1 over cosine of A. And tangent of A, so that is the ratio sine A over cosine A. So when we divide secant of A with tangent of A, all we're doing is we are dividing 1 over cosine of A to that of sine A over cosine A. So here cosine A and cosine A will get factored out and we are left with 1 over sine A. Now 1 over sine A, this is actually the cosecant function. Cosecant function is the reciprocal of the sine function. So you can replace secant of A over tangent of A with cosecant of A, and our final result will be 1 plus secant of A multiplied to cosecant of A, and this is what we had to show that it was equivalent to the right hand side, hence proved.